Feeling a little sick today, so I decided to stay home and try and rest up a little bit. But I'm going to get you this 4.1 lesson today on operations with polynomials. But before we do that, I just want to take a quick second and look at where we're at with chapter 4. That's the wrong thing I wanted to pull up. That's what you should have done on Friday, by the way, that anticipation guide. Remember when I was out of class. We'll talk more about that later this week after I get a chance to look at them. But this is the pacing guide for chapter 4. And you're going to see that we are going to skip a couple sections in this chapter. We're going to start with 4.1 today. We'll look at 4.3 on Wednesday. Remember, we're going to skip tomorrow because we'll do the presentations tomorrow as long as I'm back. Whatever the first day that I am back will be the day we do presentations. So if I'm back tomorrow, it'll be there. If not, it will be whatever day I'm back. And so we'll go through these sections in order here. So 4.1 with operations of polynomials today, 4.3 with dividing polynomials. Again, that'll either be Wednesday if I'm back tomorrow, or it'll be tomorrow if I'm not back Wednesday. And we won't do the whole section there because we'll talk about synthetic division, but really, and I'll kind of briefly touch on long division, but it won't be a too terrible section because you'll see that most of that standard is in pre-calculus anyways. 4.4, we're going to talk about graphing polynomials, and so we'll take 2 days on that, just time to be able to talk about those polynomials. I'll do most of the lesson on day 1 of that, and then give you time to work on it in class, and we'll do a little bit of an activity the second day. 4.5 on analyzing graphs of polynomial functions, and then we'll see that you have a mid-chapter quiz here on those 4 sections. And then we'll do 4.6 and 4.9. 4.6 on solving polynomial equations, that'll take us a day, and then 4.9 on the roots and zeros of polynomial functions and how we find and work with those. And then we'll review and we'll test. And so you see that take us about 10 days. But 10 days would take us beyond the end of quarter 3. So understand that this chapter 4 test will be the first test of 4th quarter. Okay, so we might throw in one more assessment. You know, you've got a couple of grades that I've got to put in for y'all this week, but we'll talk about that later. All right, so as we look at 4.1, today's objective is that you'll be able to multiply, divide, and simplify monomials, including involving powers, and then abstract and multiply polynomials. And this falls under the standard of A2.APR1, being able to add, subtract, and multiply polynomials and understand that their operations are closed for polynomials. And so properties of exponents, this is a review from middle school. So again, product of powers, remember if you have 2 bases with the same multiplying together, you will add those powers. So the example here, quotient of powers, negative exponent. Remember if you have a negative exponent, that's going to take that base and move it to the denominator, and the power changes from negative to positive. And remember the reverse is also true if the negative is in the denominator. Again, the exponent's negative, not the base. And we move from the denominator up to the numerator. Power of a power, we'll take the 2 powers and we'll multiply them together. And so 3 times 5 will give us 15. Power of a product, remember that power is going to go to all multipliers inside. And don't forget, like 2x cubed, right? So the cube will go to both the 2 and to the x to get 8x cubed. Right? Same with power of a quotient. The power will go to both numerator and denominator. And if the numerator or denominator happens to be a product, we'll combine those 2 properties together. And the 0 power property, anything to the 0 power other than 0 is 1. So like 7 to the 0 is 1. And it can be a really simple case, it can be a really complicated case, one we'll see later in these notes. Okay, so remember to simplify monomials. A monomial expression is completely simplified when there are no powers of powers. Each base appears exactly once with the same, or sorry, we're talking about monomial here, so each base appears exactly once. All fractions are in simplest form, and there are no negative exponents. And so just simplifying some expressions here, we'll see a to the negative second times a to the third, b to the fifth, times c to the negative second. So again, going back to our rules, no negative exponents, and every base can only appear once. So I'm only going to have one a in this problem when I'm done, one b, and one c, unless something were to cancel. And so remember, negative exponents will go to the denominator. And I can also multiply first and see if they're just going to become positive. Because a to the negative second, a to the third, I'm going to add those 2 powers. So negative 2 plus 3 is 1. So I get a to the first. And I've got b to the fifth and c to the negative second. And the negative piece, remember, is going to switch its position. So it's currently not in a denominator, so it's going to go to the denominator. So I'm going to get a, b to the fifth, over c squared. One thing I want to point out in the directions real quick, just remember that assume that no variable is equal to 0, because if we do need to move something to the denominator through our properties, our base cannot be 0, right? Because then we'd be dividing by 0, and, you know, that doesn't work. All right, really simple problem here. N to the 4th over n to the 7th. Remember, what are we going to do here with these two? Well, it's a quotient, so we're going to subtract the power. So I'm going to get n to the 4 minus 7, which is n to the negative 3. But that's a negative power, so it needs to move to the denominator, so I'm going to get 1 over n cubed. Just remember here, and there's some, if you go out online, you'll see some other methods that'll shortcut this step, looking at, you know, which of the exponents is larger and things like that. But again, my philosophy is that if I teach you the properties, you should be able to get from one step to the next. It may not be the shortest method, but you're sticking with the properties involved, okay? Example C here, we got a couple things going on. So 4a cubed over b to the 5th squared. So remember, this is a power outside. There's nothing inside to simplify first. Again, if we had something there, maybe we would, you know, if I had like 4 over 6, we could reduce that to 2 over 3. If I had a's or b's that would combine, we would do those first. But because we don't, this square is going to go to everything inside. It will go to the 4. It'll go to the a cubed. It'll go to the b to the 5th. So I'm going to get 4 squared times a cubed squared all over b to the 5th squared. And so 4 squared, 16. These powers are multiplying, give me a to the 6th. And these powers are multiplying, give me b to the 10th. So again, this is power of a quotient property first, but the numerator is power of a product property. So we're really using two properties here to simplify this. And this is the most simplified it can get. D, simplifying the expression here, we've got all of this involved. So, you know, 4 over 6 reduced to 2 over 3, a to the 5th and a to the 4th, so 5 minus 4 is 1, negative 2 minus 9 gives negative 11. Now, we could do all that, but I want to bring your attention to something out here. This is all being raised to what power? 0 power. And so, remember what our property says about the 0 power. Anything to the 0 power is what? 1. Now, one key caveat, and this is why we need this caveat here, because no variable equals 0, because remember, 0 to the 0 does not work, and we can get into why that is if you're a little confused on why that doesn't work. 0 to the 0 is not 1. 0 to the 0 is not 0 either. We can talk about why it could be both, but it's actually neither. But that's a discussion for another time. And so everything here is to the 0 power, so everything to the 0 is just going to give me 1. All right, so let's move on from monomials. And remember, monomials are things that have one term, right? Mono, one, right? But the degree of a polynomial is the degree of the monomial with the highest degree. Now, let's talk about degrees of monomials real quick. So just reviewing from Algebra 1 for a second. So like if I have x to the 3rd, y to the 4th, and z, this degree, and when we talk about degree, we're talking about the powers. So 3 plus 4 plus 1 would give me 8. So this is a monomial because it's just the product of variables here, and I could have a number in front like 4. But the degree would still be 8 because the number has nothing to do with it. It's just the powers. And remember that the z has a power of 1 that is there. Okay, and so just remind ourselves of the terms again. This is stuff that we should have gotten in Algebra 1, just kind of doing a refresher here. The 0 term is called what? What would we call a 0th degree function that doesn't have any x involved? Well, it's a constant function, right? Because it's just the same number all the way across the coordinate plane. And then first degree, so that'd be like 3x plus 5. Well, that is, Charles, a what? It's a linear function, right? Second degree, we talked about all that in chapter 3. Those are quadratic, right? Because, you know, it creates a quadratic function. That's the degrees, and these terms go together. A third degree function, or a third degree polynomial, is a cubic function. A fourth degree function is called quartic because of the prefix quart. Remember, there are 4 quarts in a gallon. And if you've ever known somebody who had 5 babies at the same time, not twins, not triplets, but they had 5 babies at the same time, what are they called? There's a TV show back in the day, but they were called the quints. And so this is a quintic function. 6 plus, there's no names. You could technically use certain prefixes to get there, but mathematically, we got lazy. And so everything above is just 6th degree, 7th degree, 8th degree, and so on. I don't know why in the history of math we didn't give these higher degrees more terms. It's just how it is. And so remember that to be a monomial, there's a couple of restrictions, right? We can't have our variables be in the denominator. We can't have them under a radical. We can't have them as an exponent, right? And so those things also still qualify us in terms of polynomials, because a polynomial is just the sum or difference of multiple monomials, right? So I could take like 4x plus 3y plus 7z. That's a monomial. And I'm going to have powers here even. That's a monomial. That's a monomial. And that's a monomial. It's a collection of 3 monomials. So 3 monomials will be called a what? Trinomial, right? Because tri means 3. And so we look at these polynomials here to determine if it's a polynomial, and if it is, what is its degree. And so remember those rules, right? The rule is that the variable cannot be under a radical in the denominator of a fraction or in the exponent, right? And so in this first example, c to the 4th minus 4 square root of c plus 18. Determine what is a polynomial. Well, go over what I just said. Not in the denominator of a fraction. So if there's no fractions, we're okay. It's not the exponent. The c to the base, it just can't be the power, right? And what was the third thing? Oh yeah, it can't be under a radical. And so this square root of c that is here tells us that this is not a polynomial. Okay? We look at the next example here. So negative 16p to the 5th plus 3/4 p squared q to the 7th. Determine whether it's a polynomial, and then if it's a polynomial, state the degree. And so one thing that I like to do, especially with my lower level classes, every time you see a plus or minus sign, just put a line in between it, because that's what's going to separate your terms. And so what is the degree of this first term? Well, there's only one variable, and it's to the 5th power, so this is a 5th degree monomial here. And then we look at this term. The 3/4 doesn't do anything for us. There's no variables in the denominator, so we're safe there. And then we take the variables and we add their exponents, and 2 plus 7 is 9. And so we take the highest of those numbers. We don't add them. We don't multiply them. We don't do anything like that. Again, it is the highest degree monomial becomes the degree of the polynomial. And so this is a 9th degree polynomial. And just again, reviewing from Algebra 1 a little bit, there's 2 terms here, so this would be a binomial, right? Because bi means 2, okay? Remember, the word poly just means many, but it is the encompassing term for all terms, including monomials. Monomials are considered polynomials because they are, that's just the definition of polynomials, is that it includes monomials, okay? Last one here, x squared minus 3x to the negative 1st plus 7. Is that a polynomial? If it is, state the degree. Well, so I've got x squared, that's fine. Then I've got x to the negative 1st, right? But where would that x to the negative 1st go? It would go to the what? Denominator. Now again, remember the 3 wouldn't, right? Because that's not attached to that power. But the negative 1st would take that x to the denominator, so it puts a variable in the denominator. So is this a polynomial? The answer is no, not a polynomial. Why is it not a polynomial? Right there, that's the issue. Because, again, we can't end up with a variable in the denominator of our expressions, okay? So just a couple more here. Let's look at D and E. Take a second, pause here, look at D and E, think about them for a second, see what you get. All right, so on D, how many terms are there? Well, there's 2 terms, right? And so what's the degree of the first term? So it's the a squared and the b cubed, so that's 5. And then c is just 5. So they're both 5. We're not going to add the 5s. We're not going to multiply 5s. We're not going to do any of that. We just take the highest number we have. So this is a 5th degree polynomial. And so remember, that word is quintic. Because remember, if you have 5 babies at the same time, Lord help you. And the diapers that you would have, but it would be a quintic function, or a quintic polynomial in this case. And then on E, so we've got a square root here. So is it a polynomial? No. Now, again, one thing I want to stress. You need to simplify, because what if you had a negative exponent in the denominator of a fraction, dealing with a variable? Well, the two would negate each other because you'd have the negative exponent moving that back up to the numerator. Okay. So remember with polynomials, when we add or subtract them, remember that we can only add or subtract like terms. And so with the subtraction here, remember that subtraction will affect everything in the parenthesis that follows. Cubed plus 5a minus 7 minus a cubed plus 3a minus 2. Now, if you're fine with dealing with these signs in your head, I have no problem. You just combine like terms, doing subtraction, 2a cubed minus a cubed, and get your answer here. This is not a difficult problem. And again, a lot of this is from Algebra 1. This is a lot of review, just with higher powers as we go along. And so 2a cubed minus a cubed is a cubed. 5a plus 3a, because again, I've distributed the negative now. I'm just dealing with the signs that are in front of each individual term. So 8a, and negative 7 and negative 2 gives me a negative 9. So the final polynomial would be a cubed plus 8a minus 9. We look at this addition problem. Remember, combine your like terms. So pause here for a second. Do this one. All right, so we're going to get the 4x squared plus the negative 2x, right? Squared. And so 4 plus negative 2 is 2x squared. Negative 9x plus the negative 5x is negative 14x. And positive 3 plus negative 6 is going to give me a negative 3. And so this is 2x squared minus 14x minus 3. With addition, it's a little easier because the signs are just the signs that are in front of them. With subtraction, you've got to think about double signs happening. So like this 5a would be minus a negative 3a. Double negative becomes positive there. So just be careful with those. Example 4, simplify using distributive property. Remember that if I've got a number or variable out front, remember it'll distribute to everything inside that parenthesis. And when we talk about distributing to everything inside, we're talking about each term. So we're not multiplying to every single variable or every single little thing. We're talking about separating everywhere we have a plus or minus sign, right? And so we're going to get negative 4y to the third minus 2y squared plus 3y. And that's it, because there's no like terms to combine after that. Had there been, we would have done it beforehand. Okay. If you're hearing that sound in the background, that's the jets, because that's how close I live to Shaw Air Force Base. But I'm going to record right over them because I checked it earlier in the video and I can still talk over them in the house. Negative x squared, or negative x times 3x cubed minus 2x and plus the 5. And so negative x times 3x cubed is going to give me a negative 3. Remember, we're adding powers here. 1 plus 3 will give me 4. So negative 3x to the fourth plus 2x squared minus the 5x. So again, just multiplying out, there's nothing else to combine there. All right, so in example 5 here, we're going to look at writing a polynomial expression. A small online retailer estimates that the cost in dollars associated with selling X units of a particular product is given by the expression 1/1000th x squared plus 5x plus 500. And the revenue of selling X units is given by 10x. And so we're going to write a polynomial to represent their profits. And remember, profit is revenue minus cost. And so the revenues are 10x. And so my P of x is equal to, now again, they want an expression here. I'm not going to use the P of x because technically that's an expression, not an equation or a function. So I've got the 10x minus the entire cost. Well, the entire cost is this. So the 1/1000th x squared plus the 5x plus the 500. Now, again, this was given that the cost are this, right? And so if I plug in x for here, I'd have the 500 plus 5 times 100, right? And then 100 squared times the 1,000th, right? And so we're going to get 10x minus the 1,000th x squared minus 5x minus 500. So we'll combine like terms, the negative 1,000th x squared. You got 10x minus 5x, that is plus 5x, and then minus the 500. And so this would be the resulting polynomial expression. And again, if we want to take it to a function, we could have like the profit of x in front. And so let's look at example B. Olivia has $1,300 to invest in a government bond that has an annual interest rate of 2.2% and a savings account of 1.9%. With a polynomial for the interest she will earn in 1 year if she invests X dollars in the government bond. So some people try to make these really complicated, but it's really not. You've got $1,300 to split between two accounts. So one account will get X dollars, right? Now X dollars could be $100, it could be $800, it could be $1,000, right? It could be $1,299, it could be the whole $1,300 if we want it to be. But if we're trying to total to the 1,300, right? So the blank equals 1,300, right? Well, what would fit in the blank? Well, it's whatever number would be 1,300 minus the x, right? Because we could put like a little y here, right? And so to figure out what we're going to invest, we're going to do the 2.2%, so that's 0.22 times, and let's just use the x for that one. So x will represent the amount of money that we'll put to the government bond. And then it'll be plus the 0.019 times, and it's going to be the 1,300 minus the x. Now we can multiply this out, 0.022x plus 0.019 times 1,300, which is 24.7 minus the 0.019x. And so combining like terms here, we're going to get 0.003x plus 24.7. And so remember what this is going to represent here. We're going to get $24.70 no matter which account we put in, because one's going to get the 1.9% interest either way, because this one gains more than 1.9% interest. But this will be, depending on how much I put into the 2.2%, will be what we get additional. So if I put, let's say, $1,000 into the government bond, I would get an additional $3. And it's kind of sad, but that's how interest works. All right, multiplying polynomials. Again, this should not be anything new. Just want to remind you of another method, because we could rainbow this out and everything, but as we get to larger scale polynomials, multiplying them together, we want to have methods to organize our work. And so a lot of you have used like the lattice method before to do multiplication. We don't need the boxes. Well, we need the boxes, but we don't need the diagonals going through. So I'm going to put a squared plus 3a and minus the 4 on the top. I'm going to put a plus 2 along the side. And then each box, kind of like Battleship, I'm going to just multiply what's going to match row and column. And so we're going to get a cubed here. This will be 3a squared minus 4a minus 8 plus 6a and 2a squared. And so we're going to combine like terms. Now, they won't always be along diagonals like this. Just depends on the terms that we have. But 3 and 2 will give us 5a squared. This will give us positive 2a, and this will be minus the 8. And so multiplying these two polynomials, that's what we get. Now again, we could technically write this vertically and multiply out, right? When we think about multiplying this, so 2 times the negative 4 and all the way across, we can multiply that way. There's nothing wrong with doing that. It's just, again, different ways to organize our work. Okay, I'm going to skip this example because it's exactly like example 1 that we just did, and that's it. That's what we're looking at in this section, adding, subtracting, and multiplying polynomials, and being able to tell, if things are monomials and their degrees. Again, a lot of this is review from Algebra 1 with just a little bit of an expansion going into higher ordered, higher degree polynomials. And so that's it. Y'all have a great day. I hope to see y'all tomorrow. I hope I feel better. And the word of the day is sick, because that's what I am. And I hope to get over this mess by getting some sleep. So y'all have a great day. Bye.